Alright, so we are going to now start 4.3, and I am kind of cutting a little bit out of 4.3. This is a big chunk of 4.3 starts us off with polynomial division. Okay. Now, if you remember division, this is an example of a good division you might remember. The number inside is your dividend. The number outside is your divisor. This would be like 26 divided by 3. Okay. So if you remember how to divide, you take the 3, this would be what, 7 times, actually 8 times, or subtract, you get a 2, right? This 8 is what's known as your quotient, and the 2 was our remainder. Okay, which means if you took 26 divided by 3, you actually get 8 and 2/3 as an answer. Now, how did I get the 2/3? That's the remainder over your divisor. Okay, remainder over divisor. Okay, now in this case I did have a remainder. Okay, now over here, if you look at this, here's my dividend, there's my divisor. 8 goes into 32 4 times. To 32, subtract, get a 0, bring down the 8, right? Goes in once. And here you get a remainder of 0, so you get 41. Okay. Now, what does that mean when you get a remainder? Well, when you get a remainder, that means 8 is a factor of 328. Okay, which means it's a solution to that division problem. Because anytime you get a remainder of 0, you get a solution. Okay. Now, there are 2 ways to divide polynomials. Okay. Now, if you look at this, here's a couple examples of division of polynomials. Well, the 2 different methods is long division, which is what this is up here. Okay. And then what's known as synthetic division. Well, in this course, you don't really need to know how to do it long division wise for what we need you to be able to do. Okay. There are some more courses that you do need to long divide. You're not going to have a lot of time to do that. If you really want to know how to long divide, look at the videos that they give you in the beginning of 4.3. Okay. Now, since I'm only teaching you synthetic division, whenever you have to divide by polynomials, you can use synthetic division. If they tell you to use long division, you should be able to use synthetic on it. Okay. Now, the thing about synthetic division, it's basically a kind of process math. It means we have to set things up. Okay, so if you look here, here is my dividend, and this is my divisor. So I have this long polynomial, degree 3, and we're dividing by degree 1. Okay, now if you notice, these have to be in order, highest to lowest. Okay. Now, so I have 3, 2, 1, and 0, right? So, what we're going to do is we're going to take each of their coefficients. So we're going to take the 2, the 4, the negative 3, and the 10. Remember, this is a process. It's kind of nothing you've seen before. And we're going to take what is the solution to x plus 3. Set that equals 0, we get x is negative 3. So what we're going to do, we're going to put this little half box here, and we're going to put this line underneath. Okay? So, we are going to take this value of negative 3, and it's going to go in this box. Okay? And the way this works is as follows. Okay? You're going to bring down the first number every time you get a 2. And what you're going to do is you're going to take the box, multiply it times the 2. So we're going to multiply those, we're going to get negative 6. And that negative 6 is going to go underneath the 4. Okay? And then what we're going to do is we're going to add those, which is going to be negative 2. And then we'll repeat. We'll repeat, that's going to be 6. Okay? We're going to add those, that's going to be 3. We're going to repeat again. Negative 3 times 3 is negative 9, and we're going to add, we're going to get a 1. So what do these numbers mean? Well, this 1 is my remainder. The 3 is going to be my constant to my quotient. The negative 2 is going to be the number in front of x. And this 2 is going to be the number in front of x squared. Okay. So what we're going to get is, when we take this number, it's going to be 2x squared minus 2x plus 3. And then remember how we took the remainder over the divisor? We're going to do 1 over, that's my remainder, over my divisor. Remember what our divisor was? X plus 3. And this is the proper form of writing your quotient with remainder. Okay, it's called a remainder theorem property, in which you write it like that. Okay, so notice the 2 of the x squared, negative 2 with the x, 3 with no x, because it's a constant, and 1 is my remainder. And you have to have the signs that are proper. And I always put a plus sign here. Even if 1 here would have been a negative, I do a plus with a negative 1, and it should still work. Okay, so let's do one more. Now this one, notice it's not in order. Okay, I have 4, 3, nothing, and 1 right here. So I need to put them in order first. So it's going to be 3x to the 4th minus 8x cubed. But if you notice, there's no x squared. So what we're going to do is we're going to put a 0x squared, okay, plus 10x plus 3. Okay, so now we're going to take those front numbers, 3, negative 8, 0, and that's important, that 0 has to be there, 10 and 3, put our box. Okay, now what number makes this 0 here? It would be a 2, so we put a 2 there. 2 minus 2 is 0. Alright, so we're going to follow the same rules. Bring down the front number. So 2 times 3 is 6. Add, multiply, add, multiply, add, multiply, and we get 7. Okay? So we're going to have 3, negative 8, be sure I did this right, 0x squared, x, and 3, yeah, that's right, that's a 3. I was thinking this was supposed to give me a remainder of 0, but it doesn't look like it's going to. Maybe I got the problem wrong. Alright, so what ends up being my answer? Remember, that's my remainder. This is my constant. This goes with x. This goes with x squared. And this goes with x cubed. So we're going to get 3x cubed plus, minus 2x squared minus 4x plus 2 plus 7 over x minus 2. Okay? Alright, so what happens if you get a remainder of 0? If you get a remainder of 0, then the divisor is a factor of the dividend. And that is something that we are going to be using later on as we use this skill. Okay? Alright, so some of the other stuff we can do with synthetic division. Okay? So, in terms of synthetic division, we can actually evaluate a polynomial at a certain number. Okay? Now, normally, if I asked for you to find p of some number, we've done this before, we just put negative 2 here, put negative 2 here, put negative 2 here, and figure out what the number is. However, you can do this using synthetic. Okay, and what we do is we, again, make sure it's in order. 3, negative 21, negative 1. And in the box, what we're going to put in the box is the negative 2. Okay, so we're going to put the negative 2 in the box, bring down to 5, multiply, negative 10, add, negative 7, multiply is 14, add, we get negative 7, multiply is 14, we get 13. Now, what's my answer? My answer is this value right here. Okay? So, if I evaluate a negative 2, if we put negative 2 in everywhere, the answer is going to be 13. And it's whatever this number. I know that's where we know how the remainder, but that's not the question. We're just asking to evaluate negative 2. And whatever numbers ends up at the end, that's going to be the answer. Okay? So, what happens if I evaluate it at I? In other words, inside the box, we're going to put I. Right? So, well, what are my coefficients? Well, what number is in front of here? That's a 1. So, it's 3, 2, 1. Okay, so that's a 1. There's a negative 1. There's a 1, and then negative 1. We're going to bring down the 1, and we're going to multiply. I times 1 is I. We're going to have to use some old skill that we learned before spring break. We're going to add these. That's going to be negative 1 plus I. And then we're going to multiply. So what we have to do is I times negative 1 plus I would be negative I plus I squared. And if you remember, I squared is negative 1. So this would be negative I minus 1. Now we're going to add that up. Notice the 1's cancel if there's a negative I. And then we're going to go I times negative I, which would be negative I squared, which would be negative negative 1, which is 1. So that's going to be a 1, add up and you get a 0. So this answer is 0. Okay? So it's kind of a nifty little tool. Alright, so next thing we want to do is we want to be able to find zeros. It says here, this is example 8 in your book in 4.3. Find the zeros given 1, 0. So here's my polynomial, and it says we want to find the rest of the zeros. Okay, and what we have to remember is zeros is the same thing as roots, right, or solutions. And in these cases, x-intercepts. Okay, and we know one of them is 2. So we're going to use synthetic. So we're going to set up the synthetic using these numbers. And in the box, we're going to put the 0 in that we know. Now, what does it mean to be a 0? Technically, what it means is this. If this is truly a 0, when I run it through synthetic, I'm going to get a 0 right there. Okay? So let's see. Put a 3 here. That's going to be 6. We're going to add. That's going to be 2. We're going to add. That's going to be 10. And we get, we get 0. Because it is a 0. So, if you remember, this is going to be remainder, constant, x, and x squared. Okay? So we get what they call a depressed equation. That depressed equation would be 3x squared plus x plus 5 is equal to 0. And this is something we should be able to factor. If you can't factor it, put it in quadratic formula. So we're going to use, I'm going to use this other method, x and x, numbers that multiply to 15. That add up to 1. Okay? Well, that's not a very good number. So, what I'm going to do is I'm going to look at something real fast. I hate these books. Okay, I'm going to make sure I copy that problem right, because that should not have worked that way. So let's see if I copy that problem right, because I hate to retake this whole thing. Alright. Oh yeah, I did it right. Alright, so this does not factor. Okay, that's what stinks about it. So what we have to do is now we have to take that depressed equation and put it in quadratic formula. I just want to make sure before I did it. So remember quadratic formula. square root of b squared minus 4ac all over 2a. So I have a 1 here, so it'll be negative 1 plus or minus 1 squared minus 4 times 3 times 5 all over 2 times 3, which is going to be negative 1 plus or minus 1260, 59, yep. Be the square root of negative 59 over 6, which is going to be negative 1 plus or minus I root 59 over 6. Okay? Now, how do I have to write that in your homework? That's not the fun part. It's going to be negative 1 over 6 plus I root 59 over 6. And the other answer would be negative 1 over 6 minus I root 59 over 6. So those are my other two solutions along with the 2, which means you also have to include the 2. So your final answer is going to be each of those and then also 2 in front of that. Okay? Because those are all the answers. Okay? That's the example 8 they give you. And again, it's in your book. If you want to see it. Okay? Alright, so one of the last things we want to look at, and we're going to kind of combine it with the last unit too, just to have a little refresher for you, is they say find, this is example 9, find a 3-degree polynomial with the zeros 3, 3, and negative 5. Well, they're telling you what the zeros are. It's 3 degrees, there's 3 solutions. Okay? So, how do I find the polynomial? Well, that polynomial is going to be factors that you would get 3 from. So how would I find a 3? I'd be x minus 3, correct? So it's going to be x minus 3 times x minus 3 times x plus 5. So each of those get their own factors. Okay, so these are zeros. These are factors. Okay, now from that we're going to multiply this out. These two together is going to be x squared minus 6x plus 9. And then I'm going to multiply those out. So it's going to be x cubed minus 6x squared plus 9x plus 5x squared minus 30x plus 45, which is going to give me the polynomial in degree 3, like I said, x cubed minus x squared minus 21x plus 45. And there's my third degree polynomial. Now what I want to do is also want to show you how we would graph this from the last unit. If we go back to 4.2, how would we graph this? Well, if I have zeros at negative 5 and 3 and 3, wouldn't the 3 and 3 be a double root? So at 3 here, you'd have a double root. Okay, you're also going to have our single root at negative 5. So here's 3. Okay, and if you look here, it's odd, positive, so I'm going to have an arrow down, an arrow up. There's my end behavior. Now, where's my y-intercept? My y-intercept is going to be here at negative 45. Maybe at 0, 45. It's always the constant. Put a 0 here, 0 here, 0 here, you're left with 45. So up here at 45 is my y-intercept. So this graph, being a single root, is going to go like this, going to go through the 45, and it's going to come back and it's going to bounce at 3 and graph here. And if you wanted to see that in the graph, you'd probably have a hard time finding 45. You'd have to zoom out a bunch, but that's how you would actually deal with that problem. Okay? So, I want you to be aware of how you would go about finding that. Now, we're going to practice a little bit more on the synthetic in 4.5, where we're actually finding the rest of the roots, kind of like we did example 8. Okay, so that is 4.3. And again, the videos in the book are also good. Okay.